Alright, hi there guys. We're going to go ahead and talk about prime factor trees. When we go ahead and talk about prime factor trees, we need to remember the word prime. Prime means that a number only has one factor pair. It's the number that we start with and 1. That makes it prime. If it's composite, we're going to add a caret. That's going to help make our tree. And to circle the word prime means we're going to circle all our prime numbers. So I'm just going to show you what this looks like to begin with. And let's go ahead and take the number 36 and break it apart. Today we're going to see composite numbers. So we're going to start with a tree. Here's what part of your worksheet looks like. And so you can kind of see that I'm going to follow the same tree. I'm going to use a multiplication chart to find two numbers that can multiply up to 36. I have a really big multiplication table here, so I'm not going to use my ones. Ones don't get me anywhere real fast, and I want to get this problem done quickly. So I'm going to look at 2's. 2 times anything, 36, and I see 36 right here. So what two numbers make 36? I can hover over it and it tells me 2 times 18 is 36. So I'm going to go back and I'm going to write 2 times 18 equals 36. In our room we have a prime composite chart. 2 is a prime number, so prime numbers get circled. 18 is composite, so it gets another caret, it gets another branch of the tree. So what two numbers can equal up to 18? I'm going to try 2 again because I know 2 and 18 are even, they're kind of related. 2 times 9 is 18. See that pop up there? 2 times 9. So now I'm going to write 2 times 9 under this branch. 2 times 9. 2 on our prime chart. 9 is composite, so it gets another branch. Break this apart. Let's use our hundreds table. 2 times anything, 9? Nope. How about 3? Whoop. 3 times what? 3 times 3 is 9. So if I come under here, 3 times 3, and both 3's are prime. This is the prime factor tree for 36. Later we'll get used to writing it like this. 2 times 2 times 3 times 3. And those dots mean times. But we're breaking a bigger number into lots of little numbers that multiply up. If I take my calculator to try, and I just plug this in, 2 times 2 times 3 times 3, what do you think I'll get? The original number. So we're looking for a group of numbers that are prime that equal 36. And we do so with prime factor trees. So let's go ahead and look at your worksheet. We start with 250, and they break 250 down into 50. So this is going to be my clue on where to look on my hundreds table. So I'm going to pull that back up. I'm going to go all the way down to 50. Here's 50. And I'm going to go across until I find that 250 number. Here it is. The fact is 50 times 5 is 250. Remember that. 50 times 5 is 250. So when I get to 250, they already gave me 50. So I'm going to add the 5. I'm kind of filling in the missing numbers right now. Now, because they gave 50 carets, that means that's composite. So 5 has to be prime. So I'm going to circle that prime number. What two numbers can I break 50 into? Well, they gave me 1. They gave me 10. 10 times what is 50? Let's go back to the multiplication chart. Not that. Yes. 10 times what? So I'm going to jump back up to 10 because they gave me that. 10 times what is 50? Here's 50. 10 times 5 is 50. So there's another 5. I know I can look up in the chart in the room. 5 is prime. And now I have to break 10 apart into 2 more factors. Let's go back to our multiplication table. 10 times what? Or what can I break 10 into? Can I use 2? So I know 2 is prime. 2 times 5 is prime, and so far 5's been prime. Two's prime, 5's prime. So I have 5, 5, 2, 2. And once I've completed all the branches and have circled the prime numbers, only prime numbers, remember we're only circling prime numbers. Okay, we're only circling prime numbers. Let's go ahead and look what number 2 looks like. Number 2 looks like it's missing a composite number right here. I say it's missing a composite number because it's got carets already set up underneath of it. And 5 is prime, so I'm going to circle that 5 because it's already prime. I started with 75. So 5 times what number is 75? Let's go back to our multiplication chart and look for 5 and 75. 5, 75, 5 times 15 is 75. So it looks like this missing number is going to be that 15. 15's composite. I can break it down. What are 2 numbers that I can get to 15? Well, 2 doesn't work. 3's another prime number, so let's try 3. 3 times 5 is 15. So I'm going to use 3 and 5. Look at my chart in the room, and I know that 3 is prime and 5 is still prime. So I have the prime factorization of 5, 3, and 5. This is how you find prime factor trees. You have numbers 3, 4, 5 and the homework to complete. Ask questions when you need help, and I will be glad to help. If you don't understand anything, you have to ask questions. That's how this video will work. Alright guys, get to work.